Good morning, everyone. Today we are going to start with a new topic, arithmetic progression. Let us now understand the meaning of arithmetic progression. Let us first understand the dictionary meaning of arithmetic progression. An arithmetic progression is a series of numbers that increase or decrease. Remember, it increase or decrease by the same amount. The progression doesn't mean it always been increasing. It can increase or decrease by the same amount. Let us now consider some examples. We have our first example, 8,000, 8,500, 9,000. Again, these list of numbers are following certain patterns in it. As you can see, they are increasing by 500. Next is 2, 4, 6, 8. Again, they are following some definite pattern. They are increasing by 2. Now we can see some more example. This is a sequence which is decreasing. It's 45, 43. It is decreasing by 2. Again, we have one more example, 100, 50, 0, minus 50. They are again decreasing by 50. So these are the arithmetic progression which follow some definite rules. They are moving in some patterns. So by these examples, we can now define our. Let us now define sequence. What is sequence? Sequence is a set of numbers arranged in some definite order and formed according to some rules. Rules means that we have just seen. Rules means some patterns. As we have seen in our examples, they are following some definite patterns. They have a constant term in it. Progression. Let us now understand what is progression. That is again the same thing, the sequence that follows a certain pattern. As we have seen in our examples, they are following certain patterns. Now, understand some more examples of this. Now you can see your first example 1, 3, 5, 7, 9. Now each term is obtained by adding 2 to the previous term. Next example is 10, 8, 6, 4, 2. Now each term is obtained by adding minus 2 to the previous term. Like 10 minus 2 will be 8, 8 minus 2 will be 6, 6 minus 2 will be 4, 4 minus 2 will be 2. As in the next example, minus 3, minus 2, minus 1, 0 and goes on. Each term is obtained by adding 1 to the previous term. When we add 1 to the minus 3, we will get minus 2. Minus 2 plus 1 will be minus 1 and so on. And the last example which I have written is 5, 5, 5, 5. Each term is obtained by adding 0 to the previous term. Again, it is having. Now we can define our arithmetic progression as. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to a previous term except the first term. That means we are having our sequence of numbers which are obtained by adding a fixed number to the previous term. We are adding a fixed number to the previous term except the first term means that we are having our first term with us and we are moving after that by adding a fixed number to each term. This fixed number is called the common difference. It can be positive, it can be negative, or it can be 0. Now consider some non-examples of AP. Now I consider this. In a savings scheme, the amount becomes double after every 10 years. The maturity amount in rupees of an investment of rupees 8,000 after 10, 20, 30 and 40 years will be respectively. Now what the question is saying, if we are investing 8,000 for the first year and it is getting double after every 10 years. In the first year, our investment amount was rupees 8,000. After 10 years, it has become 16,000. Then it has become 32,000 in the next 20 years. In the next 30 years, it has become 64,000 and so on. So we can see there is a pattern in this list of numbers. In this sequence, there is a pattern, but each term is not obtained by adding a fixed number. It is getting actually doubled. Here we can find succeeding terms are obtained by multiplying by a fixed number. So they are not in AP because they are not obtained by adding a fixed number. They are getting by multiplying with a fixed number. One more example, we have shown a number of unit squares here. We have shown unit squares over here. This is of 1 unit, this is of 4, 9 and 16. As we can say, the difference of the numbers in this sequence are even again not same because they are the squares. The first term is a square of 1, then it's square of 2, this is square of 3, this is square of 4. So they are again not in AP as AP is obtained by adding a fixed number to the previous number. We can define our formula for the common difference as, let us denote the first term of AP by A1, second term by A2 and nth term by AN, and the common difference be D. Then the AP becomes A1, A2, A3 and up to AN. Here this A2 minus A1, A3 minus A2 and moves on. If the subtract first term from the second term or second term from the third term, we can have our common difference. So we have a formula as an minus 1 is equal to D. So D is second term minus first term, or we can say third term minus second term, all the differences in this AP. So the general form of an AP will become A plus D. This is our first term A. We add D to it. This is our second term. Then we again add D to it. We'll get third term. Then again we'll add D to it. We'll get the next terms. This general form of an AP represents an arithmetic progression where A is the first term and D is the common difference. We now are able to define our finite and infinite APs. Finite AP is simple as an AP which is having a last term in it is a finite AP, and an infinite AP which does not have a last term in it. That AP which do not have a last term in it, that is an infinite AP, and for a finite AP which have a last term in it. Now observe the sequence. 3, 7, 11, 15, 19. What do you observe? What is the first term and the common difference in this? Here in this AP, A first term is 3 and D, that is the common difference, is 7 minus 3, that is 4. As you can say 7 minus 3 or 11 minus 7, its D is common over here. To check that given sequence is in AP or not, let's consider this AP 2, 6, 10, 14. Here the first term is 2. Let us now find the differences of the next terms. A2 minus A1 is 6 minus 2 is 4. Then A3 minus A2, that is 10 minus 6 is 4. A4 minus A3, 14 minus 10 is 4. Since the differences are common, hence the given terms are in AP. Remember, don't write D unless or until you have not got that it is in AP. Once you are sure that it is an AP, then only we can define our D, because D is restricted for the AP. So till the time we are not sure it is an AP, we just use like this: A2 minus A1, A3 minus A2, A4 minus A3. The 2 is enough to find whether they are in AP or not. Once we have, again we have find this thing A4 minus A3 in this question. Let us now consider some question of your NCERT. Exercise 5.1, question number 2. Write first 4 terms of an AP when the first term and the common difference is given to us. We are starting with the second question. We are given with and the common difference, and we have to find the first 3 terms of an AP. Here A1 is 10, A2 will be A plus first term plus common difference, that is 20. Third term will be 20 plus D, that is 20 plus 10, that is 30. So the first 3 terms of an AP with the first term A, 10 and D, 10 will be 10, 20 and 30. This is our first term, this is our second term, and this is our third term. And if you need to find the next term, it will be again this A3 plus the common difference, that is 40. Let us now start with question 3. For the given AP, write first term and the common difference. This is an AP given to us. Here A is 3, and if you have to find the common difference, what will be the common difference? The common difference will be A2 minus A1, that is 1 minus 3, that is minus 2. So A is the first term, that is 3, and the common difference, that is minus 2. Let's start with question number 4. Which of the following are APs? If they form an AP, find the common difference and write 3 more terms. We have this question with us 2, 4, 8, 16. We have to first check whether it is an AP or not. And if it will be in an AP, then we have to find the common difference and first next 3 terms of this given AP. So here we have an AP. Here first term is 2. Now we will not write the word D till we are not sure that it is in AP. Because if it is in AP, then only we will be using the word common difference in that. Otherwise, we will be writing A2 minus A1, A3 minus A2 and so on. So A2 minus A1 is 4 minus 2, that is 2. A3 minus A2 is 8 minus 4, that is 4. That means they are not same. And if it is not same, that means A2 minus A1 is not equal to A3 minus A2, which gives us the result that this list of numbers is not in AP. Now consider one more question. 3, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2. We have to check whether the given sequence is in AP or not. So here we have find out A2 minus A1, which comes out to be root 2, A3 minus A2, which you will get again root 2, which gives you a result that A2 minus A1 is equal to A3 minus A2, and hence they are in AP with A is equal to 3 and D is equal to root 2. Next 3 terms of an AP are just simply we have to add root 2 to the previous terms. Once you will add, you will get these 3 terms. Thank you.